Today we are going to discuss about route summarization.
Yes.
And route filtering. Okay.
Yes.
So route summarization and route filtering are two important topics in every routing protocol. So do you know what is route summarization?
Yeah. so route summarization is a method or technique of reducing or of helping the router to not have a lot of routes in a routing table. So if we have a continued network, for example, a slash, if we have a few slash 24, we can represent them in the routing table as a slash 16 or a slash 8, just for the router to not utilize these resources.
Yes.
Or to better utilize these resources.
Yeah, very good. So in CCNA, we learn about variable length subnet mask, right?
Yes.
So basically, what is VLSM? VLSM is technique to create multiple small subnets.
Yes.
Using a large IP subnet, right?
Yes.
So if I say that I have this 10.1.1.0.0.0/8. Now you need 5 subnets. So you'll say, okay, let me create 5 subnets. Each with 256 hosts, right?
Yes.
2.0/24, 10.1.3.0/24, 10.4.0/24, and 10.1.5.0/24. Now, in this, you can see here that using a single subnet, small, big, or you can say large subnet, I have created 5 small subnets, right?
Yes.
And I can even create more subnets also.
Yes.
This technique is known as variable length subnet mask. So this is FLSM, but yeah, this is classless, right? Like FLSM is when we have the same subnet mask for each subnet. VLSM is when you have the different subnet mask, like 10.1.1.0/24, 10.1.2.0/25, 10.1.3.0/27, 10.4.0/28, 10.1.5.0/30, like this.
Yes.
So this thing is known as
VLSM.
FLSM, and this thing is known as VLSM, variable length subnet mask. Now the route summarization is quite opposite of variable length subnet mask, or you can say VLSM. So what is route summarization now? Again, we can say that a technique used to create a summarized subnet using multiple small IP subnets, right?
Yes.
It includes the common bits of whole IP subnets, right? So basically in route summarization, what we are doing, we are counting the common bits. Like if I say I have this prefix is here, 10.1.1.0/24, 10.1.2.0/25, 10.1.3.0/27, 10.1.4.0/28, 10.1.5.0/, right? So if we have a router 1 and if we have a router 2,
yes,
12.1.1, 12.1.1. If you talk about EIGRP only here, and if I compare EIGRP in the 12.x iOS version and 15.x iOS version, right? So in 12.x iOS version, we have two modes of EIGRP, classful and classless. And by default, EIGRP is running as classful. So if routers are having,
I'm hearing an echo.
What?
I'm hearing a voice. Your voice echoes.
Your voice?
Is it? I think it's your voice. It has an echo. It repeats itself on the line.
Now, okay, just give me 1 sec. Let me connect.
Okay.
How is it now?
Yes, it's better. Thank you.
Yeah. So you know that classful and classless, right?
Yeah.
So if I run EIGRP on the iOS version 12.x, what R1 will do, R1 will automatically advertise a summary route.
Yes.
This is known as
It's a summarization.
Okay. Automatic
summarization.
So I think you remember that in that case, we have to add no summary command under EIGRP.
Yes.
To disable the automatic summarization.
Yes.
But in 15.x iOS version, EIGRP is by default classless and automatic summarization is disabled.
Disabled, okay.
Yeah.
Yes.
Now, by default, what R1 will do, R1 will advertise all of these subnets to R2.
Okay.
Okay.
Yes.
With the next of 12.1.1.1.
Yes.
So now R2 have to store 5 different prefixes. First in the topology table. Then router will calculate the prefix for each and every prefix in topology table first. Then all of the prefixes will be downloaded in routing table. So it is like फाइनेंशियल कुछ ऑपरेशन होता हुआ now R1 will advertise all of these prefixes to R2. What we will do in case of summarization, I'll try to find out the common bits.
Okay.
It includes the common bits of all IP subnets. So if we see we have total 5 prefixes here, and then we start calculating the total like common bits. 10.1.1.0. This is the smallest subnet, and this is the highest. So we'll use these 2 subnets, 10.1.5.0/30. So we can see that first 2 octets are same, right?
Yeah.
If we think about third subnet, third octet. This is the binary of third octet.
Yeah.
And this is the binary of this 5, right?
Yeah.
Now, 16 bits are already same.
Same, yeah.
17, 18, 19, 20, 21.
21. Okay.
They have 21 bits in the common.
Okay.
So R1 will say that 10.1.0.0/21. So in the topology table of R2,
Yeah.
10.0.0.0/21, then they'll calculate FD and RD.
Okay.
And then this IP subnet will be installed in the routing table.
Okay.
That next stop is 12.1.1. This is the AD value and this is the FD.
FD. Okay.
And yes.
Yes.
So now, what are the benefits of route summarization? Right.
Mm-hmm.
What are the benefits of route summarization?
Mm-hmm.
Yes.
So it reduces the size of the routing table.
Decreases the size of
The routing table.
IP routing table. It decreases the size of an
Updates. Okay. Okay.
the neighboring router has to calculate metric value
Once
only for the
some other bit.
summarized route, right?
Okay.
And fourth, which is very interesting,
Yes.
it reduces the scope of
Okay. Okay.
query messages. It reduces the scope of query
Messages.
message.
Okay.
Yeah. We will see how. See, we know about every other, like this one, this one, this one. Now, what is the fourth? Right, that it reduces the scope of query message. How is it possible? See, this is R1, this is R2, this is R3, this is R4. All right.
Yes.
Now R1 is having total 5 subnets. 10.1.1.0/24, 10.1.2.0/24, 10.1.3.0/24, 10.1.4.0/24, 10.1.5.0/24.
Yeah.
Right. R1 is having a routing table and topology table. All right.
Mm-hmm.
First one is routing table and second is topology table. All of the routers is also having the routing table and topology table.
Yes.
This is RT means routing table.
Okay.
and this is
topology table.
Topology table. So all of these IP subnets are present in the routing table of R1. When you will enable network command, all of these prefixes will be installed in topology table, right?
Yes.
And what R1 will do, R1 will calculate RD and FD. But you know that for directly connected prefixes, RD is always 0, so it will calculate only FD. Okay. Then R1 will advertise these prefixes to R2. First of all, when R2 will receive an update message, R2 will download these prefixes in topology table. Okay.
Yeah. Yes.
Then R2 will calculate RD first, and then it will calculate FD. Right?
Yes.
Then R2 will install all of the prefixes in routing table. See, in routing table, we don't install RD value, we install AD and FD, right?
Okay.
Then R2 will advertise these prefixes to R3. First of all, R3 will receive in topology table. Okay. And it will also calculate RD values. Then R3 will install all the prefixes in routing table with FD value and AD value. Right?
Yes.
Then R3 will advertise these prefixes to R4. First of all, R4 will receive in the topology table, will calculate RD value and FD value. And then R4 will install all of the prefixes in routing table with FD value and AD value. Right? And with the next job. Okay, with the next job also. But we don't have that much space to write down the next job as well. So yeah, for R4, 34.1.1.1 is the next job. For R3, 23.1.1.1 is the next job. And for R2, 12.1.1 is the next job. All right. Now, as we've already discussed that in topology table, we have two states of a prefix, passive and active. So now if the successor is present, one of the prefixes in the which state? Passive state. All of the prefixes are in
passive state.
Passive state. You can see very clearly that this is a linear topology. This is a linear topology, right? So in this linear topology, now, see, if this prefix will goes down, for example, this interface will goes down, okay?
Yes.
What R1 will do?
Send out an update. It will also, send an update.
It will think that the successor is down now.
Yes.
It will think that successor is down. So R1 will start looking for another successor.
Yes.
But as you can see in this topology, is there any possibility to get another successor?
No.
No, right? Yeah. But still, what R1 will do? R1 will send a query message. For which network? 10.1.1.0/24. It will say delay is infinite. For me, it means I don't have any route to reach 10.1.1.0/24. What R2 will do now? R2 will say, okay, who is successor for me? For me, successor was 2,
It's you.
R1. And now R1 is sending query to me. It means R1 is no longer successor router, right?
Okay, yeah.
So first of all, R1 will move to which state? Active state. And then R2 will say, okay, let me go to active state.
Okay.
What R2 will do, R2 will send just an acknowledgement, because right now R2 cannot give a reply message.
Okay.
Cannot give a reply message. Then R2 will forward this query further, because R2 is also looking for another successor now, right?
Yes.
And delay is infinite. Now R3 is also surprised. R3 will say, for me, R2 was successor, but now R2 is sending me a query message. It means I have to move to active state, and R3 will give an acknowledgement. Then R3 will forward this query to
R4.
R4. 10.1.1.0/24, and delay is infinite. What R4 will do now? First of all, R4 will give an acknowledgement, right? Now R4 will say, okay, we have to move to active state, but I do not have any further neighbor.
Yes.
So I cannot send this query message to any other router. I have to respond, right?
Yeah.
In that case, what R4 will do, R4 will remove this prefix from the topology table.
Yeah.
And R4 will give a reply message, which is also known as
negative.
Because R4 is not giving that, okay, I have a path, right? Okay. R4 is not having any path to reach 10.1.1.0/24. So this is a negative reply. What R3 will do, first of all, R3 will give an acknowledgement. Okay. And R3 will remove this prefix from the topology table, that we don't have any route to reach this prefix. Okay. So as well as from the routing table, right?
Yes.
Then R3 has given an acknowledgement. R3 will forward this query to, reply. To R2. What R2 will do now, R2 will remove this prefix from the routing table and topology table. And R2 will give that acknowledgement, right? Yeah. Then R2 will give this reply to R1. R1 will remove this prefix from the routing table and topology table, and will send an acknowledgement to R2. Yeah. This is how the prefix will be removed from the routing and topology table of all the routers. All right. Yes. Yes. This is the normal scenario. Yeah. It is. On the other hand, if we think about route summarization, again we have this topology. Okay. Let me clear it a bit. 10.1.1.0/20. This time, I'm not advertising the individual prefixes. Okay. Yes. Yes. Now, always remember that the route summarization will happen after the topology table. Okay.
Okay.
So R1 will have the individual routes in the topology table, but when R1 will advertise prefix to R2, what I did, I've configured route summarization. So now route summarization is 10.1.0.0/21. Okay.
Okay. Yeah.
In the topology table of R2, we have a prefix for which we will calculate FT, and then this prefix will be installed in the routing table. 10.1.0. Sorry, 10.1.0.0/21. Next stop is AD value is 90 and whatever the FT value.
Okay.
Then R2 will advertise this prefix to R3. This time we are advertising a summary route. So first of all, prefix will be installed in the
Topology table.
And R3 will calculate FT and RD, then prefix will go to the routing table.
Yeah.
Next stop is 23.1.1.1. 90 is the AD value and FT value.
Yes.
Then R3 will advertise this prefix to R4. 10.1.0.0/21. FT and RT will be calculated and prefix will be installed in the routing table. What is the next route? 94.1.1.1 and FT and AD value. Right. So this is how the summary route has advertised in BGP.
Yes.
Now, if we say that if again this prefix is in downstate, if this interface will go down, it goes down here and from here, right? Yeah. R1 is not having a summary route. R1 is in the topology table, it is having the individual route. So what R1 will do now? R1 will send a query message again.
Yeah.
10.1.1.0/24, and for me delay is now infinite.
Infinite, okay.
Yeah. Will do. First of all, R2 will give an acknowledgement. Okay. Right?
Yeah.
Now R2 will say, I do not have any such prefix in the topology table. But this prefix is part of summary route.
That's how yeah.
This prefix is part of summary route. If a router receives a query message for a prefix, individual prefix is not present in the topology table, but it is part of a router will not forward the query message further neighbors. Will give a reply message back to the router, sending it. Yeah, please read it.
Okay, if a router receives a query for a prefix and the individual prefix is not present in the topology table but is part of the summary, the router will not forward that query message to further neighbors. It will give a reply message back to the router sending a query message. Okay.
Okay.
Yes.
Now, if I take you to the enterprise book, Read this one, this one.
Okay. With particular respect to EIGRP summarization, it's also a powerful tool to create a boundary for query propagation. Okay. If a router receives a query for the network it does not have in its topology table, it will immediately send back a reply indicating an unreachable destination without itself going active and propagating the query further. Okay.
Okay. So route summarization also helps to reduce the scope of
Query propagation.
query messages, right?
Yeah.
Route summarization also helps to reduce the scope of query messages.
This is, yeah.
Clear? The fourth point, reduce the scope of query messages.
Okay, 100%.
How to perform route summarization. All right.
Yes.
The IGRP is a very flexible routing protocol in case of route summarization. You are allowed to perform route summarization at any route of outgoing
Update.
route summarization cannot be configured for particular type.
Okay.
You can configure route summarization on an interface. Right.
Okay.
So it doesn't matter that how many labels router having on an interface.
Yes.
Right. It is going to summarize routes for all the prefixes.
Okay.
So if we talk about this topology again, ten dot one dot one dot zero slash 20.
Yes.
Now what R1 will do here? R1 is sending a summary route. Okay. So you can perform route summarization at this interface All right.
Yes. Yes.
If you will perform route summarization at this interface, route will be summarized for R2. So R2 will receive a summary route.
Okay.
Next up is 12.1.1.
Mhm.
R2 will advertise this summary now to R3, right?
Yeah.
10.1.0.0/21. And next up is 23.1.1.1. Then R3 will advertise this to R4.
Yes.
10.1.0.0/21. Next up is 34.1.1.1.
Other one. Yeah.
This is what you can do here. All right.
Mhm.
But if you want to do the sum, if you don't want to do the route summarization for R2, for example, so for example, that if you want to advertise the individual prefixes to R2, you can do that. Okay.
Okay.
So you have advertised individual prefixes to R. Sorry, to R.
Yes.
Next up is 12.1.1. Now, if R2 wants to route summarize, so R2 wants to perform route summarization, R2 can do that
Okay.
for R3.
Okay.
See, the prefixes belongs to R1, right?
Mhm. Mhm.
But any other router can also summarize them.
Summarize. Okay.
But remember, but for only for the
Particular interface.
outgoing updates. All right.
Yes.
If R1 is advertising individual subnets, R2 cannot summarize them for itself.
Okay.
R2 have to receive all the prefixes. So you cannot summarize the incoming update. You can only summarize the outgoing
Outgoing.
updates. All right.
Yes.
Yeah. Right. So for example, if you have like this is R1, R2, R5, and R6. Okay,
Yes.
Kavusha?
Yes.
Hello?
Yes, I can hear you. Can you hear me?
Hello?
I can hear you.
Are you there?
Yes,
Hello?
I can hear you.
Okay. So now R1 is advertising the prefix to R2
Mhm.
individually, to R5, to R4, to R6, and to R3.
Mhm.
Now, if I want to perform the route summarization on R1, if you'll configure route summarization R1,
Mhm.
this route summarization will be configured for all the neighbors. So when you go to R2, or you'll go to R5, or you go to R4, you will see that all of them are receiving a summary router. 10.0.0/21, 10.1.0.0/21, 21, 10.1.0.0/20.
21.
All right. Is it clear?
Yes, it's clear.
Okay. So we cannot perform route summarization for a particular name.
Okay.
So 92. Close lab. EIGRP. Net. Start all nodes.
Are you sharing if Amit, I just see the paint drawing.
I can't hear you, Pavusto.
Yes, I can hear you. Can you hear me?
Can you hear me?
Yes, I can hear you.
Hello. Okay. Okay, please.
Amit, can you hear me? Can you hear me? Amit, can you hear me?
You can rejoin for if you don't.
Hello? Hello?
Hi, Pavusto. Hello.
Hello? Yes.
Can you see the topology?
Yes, I can see the topology.
And R1, right? Can you see the CLI of R1?
Yes.
Stripe interface B.
Okay.
What I'm doing there, we have total 3 loopbacks. So let me create one more loopback 4, 10.1.1.4/32. Interface loopback 5. IP address is 10.1.1.5.
Yes.
Now, if I go to the EIGRP interfaces, you can see that EIGRP is enabled on all the interfaces, right?
Yeah.
And if we see the topology table of R1, so EIGRP topology, you can see that all of the loopbacks are present in the topology table as well.
Mm-hmm.
When you go to VIOS 2, so IP route EIGR. You see the 5 loopbacks of R1,
Yes, you can see them.
right?
Mm-hmm.
And if you go to R3, for example, this is R3, right?
Yeah.
So IP route EIGRP, you can see that R3 is also receiving all the prefixes of R1.
Mm-hmm.
And if I go to R4, so IP route EIGR. So you can see 5 loopbacks, right?
Mm-hmm.
10.1.1, 10.1.1.2, 3, 4, 5 at slash 32.
Yes.
At slash 30,
Yeah.
right?
Mm-hmm.
Now I want to configure route summarization. So I'll go to R1 and I'll say show IP interface bit. So we are using this interface gigabit 0/0. Interface gigabit 0/0 IP summary address. EIGRP AS is 100. Now
Yeah.
what is the summary here? See, we have total 24 bits, same, right?
Mm-hmm.
And
0 W slash
24, 29, right?
29. Uh-huh.
In case of 29, it would be 248.
8. Yeah.
When you configure route summarization, you see that database is resynchronized. Okay.
Okay. Yeah.
So IP EIGRP topology. You can see still
Uh-huh.
all of the prefixes are still present in the
Topology table.
topology table. But if I go to VIOS table,
Only some.
EIGRP topology, can you see it?
Yeah. Yeah.
Two values are there, FD and R.
ID. RT.
But if we run the show IP route command, you can see in the routing table we have only FD values. So
Mm-hmm.
13816 with
Yes.
8 values 90, right?
Mm-hmm.
If we go to R3, you will see that you have only one prefix in the topology table and routing table, sorry. And if we go to R4,
Yes.
you will see a single prefix, right?
Uh-huh. Yeah.
So on R1, we were having total 5 subnets or 5 loopbacks, you can say.
Yeah.
10.1/32. 10.1.1.4/32, 10.1.1.5/32, right?
Yeah.
Now, if my condition is that R1 should advertise a summary route to its neighbors, all right?
Yeah.
But R1 must advertise
Individuals.
read it again.
Yeah. Okay, R1 should advertise summary route to its neighbors, but R1 must advertise 10.1.1.3/32 as individual prefix as well.
Right. So how is it possible if we'll summarize 10.1.1.1 0/29? 10.1.3 is the part of this summary route, right?
Yeah.
That's why we come up with the idea of a leak map,
Okay.
concept of leak map. Okay.
Leak map. Okay.
What you'll have to do here, first of all, configure an access list. You can give it a name. Standard. I've given it a name, leak, or give it a number. Then
Okay.
10.1.1.3. Okay.
Mhm.
Then route map. You can give it any name. I've given it name leak.
Okay.
Match IP address, access list.
Mhm.
We will talk about route map in detail. So route map leak permit 20. So do show run pipe section route map. You can see that in route map we have two statements total. First is with
It permit
sequence number 10 and second is
10,
with
yeah.
sequence number 20.
20.
Because in route map we have the rule of implicit denial.
Yeah.
Override that implicit denial rule, I have configured a route map statement with higher sequence number. Okay.
Okay. Okay.
Now I'll go to the interface. IP summary address EIGRP 100.
Mhm.
This was the summary, right?
Yeah.
We can see option of leak map. Here you
Leak map.
have the name of the route map.
Okay.
Now if we go to R2, it says show IP IGRP topology table.
Mhm.
So run pipe section access list.
Mhm.
So run pipe section route map. So run interface delivered 0/. So first of all, we have configured an access list, right?
Yes.
In the access list, I have matched a prefix.
Mhm.
Then I've configured a route map because on this here you cannot call an access list directly. Okay,
Yes.
so we cannot call an access list directly. That's why I have to create a route
A
map.
route map. Okay.
So access list is here.
and route map is
It's there.
okay.
Okay.
Now
Yes.
let's effect.
Okay. So the only option is link map to do this.
Yeah.
Okay, for EIGRP. Okay.
That's why it is known as leak map, because this time you are leaking a prefix, right?
The prefix, yes.
You can see that 10.1.1.3 is here, but we have the summary route as well, right?
Okay. Yeah.
So now EIGRP, you can see that this prefix is still advertised individually.
Mm-hmm.
You can see now all other prefixes are summarized, but this prefix is here.
Yeah.
So IP route AIC 10.1.1.0/29 and 10.1.1.3/30.
Mm-hmm.
This is how you can configure route summarization as well as leak map.
Okay.
All right, Augusto?
Yes.
And we can configure route summarization at any route
Okay.
for outgoing updates, not for incoming updates.
Yeah.
Yeah, so that's all for today.
Okay.
Okay. Next
All right.
class, see that how to configure route filtering.
Okay.
All right. Yeah.
Okay.
I hope you have enjoyed the lesson.
Yeah. I have. Thank you. So
See
the
you
next
on-
one will be on Monday.
Yeah. On Monday.
Okay.
Yes.
Thank you. Thank you, Amit. Have a good weekend.
Yeah. Have a good day.
Okay. Bye-bye.